Welcome to the second video in the DIDCOMM Superstack webcast series. Um, this is prototype 2. It builds on prototype 1. It takes the same DIDCOMM agent that we defined in prototype 1, and it shows how to send a credential using DIDCOMM to our DIDCOMM server. If you remember in prototype 1, we just sent an empty message, an empty JSON string. This time we'll actually be taking our credential. We'll be doing DIDCOMM compatible encryption. We'll be sending that as one of our DIDCOMM agent messages to the agent, where we will decrypt it. And to demonstrate a little bit of the Trinity graph engine storage capabilities, we're going to take that decrypted message, the JSON text, the JSON credential that we started with originally, and we're going to persist that to Trinity Local Storage. So that all makes this a little bit complicated and long. Just to make it a little more complicated, we're also illustrating sending this DIDCOMM message to multiple recipients, so to multiple subjects. And so it needs to be encrypted and decrypted on a subject by subject, recipient by recipient basis. So let's get into the code. The one nice thing is that the Trinity specification language for our server hasn't changed. For this particular prototype, we're just using some dummy JSON representing a verifiable capability authorization credential. We actually don't care what the JSON is in this particular example, because we're just taking whatever the payload is and encrypting it on a recipient by recipient basis and sending it to the DID server. But to make this a little bit realistic, so also if you're curious about what a structured credential looks like, here's an example. I won't cover that too much here, but if you kind of use these to open and close the different pieces, you'll see that there's an envelope and a proof. And if you go into the envelope, there's a label and there's the content. And so this idea of the structured credential model really helps when we not only think about these things, but as we build them out. But for this case, it's just a JSON W payload, and that's the last. We'll look at that. So in this one, just to emphasize, it's just a dummy. We're not actually creating a proof. We'll do that in a subsequent prototype. Okay, so let's go into the program. And what we want to do here is we populate our key vault. We're going to reach out into this embedded file and get a hold of some JSON just so that we have a payload. Just like before, we're going to create an instance of our DIDCOMM agent, and we're going to start it up. Then the next thing we're going to do, and this is new, this is starting to bring in some of the verifiable credential transport protocol, DID protocol level messages. So we've got a factory here for creating the 4 different kinds of messages. And so if we go in and look and see what a notify message looks like, we can see that it takes a from key ID, a string of 2 key IDs. It takes whatever the payload is. And in this case, a notify message is expecting the payload to be a verifiable capability authorization, because if we look at the comment here, the semantics of a notify message is, I have a payload for you, I have a credential for you. Here's a VCA, which will include, of course, a payload identifier or credential identifier for you to acknowledge and agree to. send me a pull message with a VCA acknowledgement confirming your agreement with the VCA, and I'll send you the payload. So while technically it doesn't matter for this particular prototype what this JSON is, to provide a little bit of realism, because we are creating a notify message, we are sending a dummy VCA. So part of the Trinsic libraries defines a core message. Core message has an ID property and a type. Those of you that are familiar with the DIDCOMM protocol will recognize these. Trinsic also defines something that I found useful, which is a basic message that just for the core payload, when you just have a string of data that you want to send, rather than getting involved with Google protobufs and creating your own structures, I've just cheated a little bit, and I'm using a basic message to create a message. The text of that message is just the VCA with a little bit of a wrapper around it. And I'm converting that message into a byte string, and I'm setting the body of my core message to be that. So in essence, it's a message wrapping a message. I set the expires property, I set the from, and I set the to. So at this point, I have a core message. I have a message in the format that the DIDCOMM libraries understand. So I'm asking the factory, the message factory, to create a notify message. I'm passing in Charlie as the originator, and I have two recipients, Delta and Echo. These correspond to two of the subjects that I've created earlier up here and who I've added to the key vault. And part of the generation of their keys is their did key string is being calculated here. So that's in fact what I'm passing in to the from and the to value for my notify message, for my core message, my DIDCOMM core message. Perhaps we'll put a breakpoint there so that we can look at that. So what I want to do now is iterate over those two key IDs, and I want to use that key ID to create an encrypted package. And so you need to use the DIDCOMM, the Trinsic DIDCOMM pack method. You need to pass in a pack request. A lot of the APIs, the Trinsic APIs, are sort of message-based, where you're creating requests and you're getting responses. So the text that I want to encrypt is my notify string, and I'm going to convert that into a byte string as a representation of my plain text. The sender key, of course, is going to be Charlie's key, and the receiver's key is going to be whatever the did::key key ID is. I'm going to use that to index into the key vault, get the public key, and use that for encryption. And out of that encrypted package, I'm going to get a message back. So I'm going to take that message, and that's what I want to send. This is what I want to send on to my DIDCOMM agent. So the first thing I have to do is I need to create a DIDCOMM encrypted agent. This is the DIDCOMM encrypted agent that we've defined in our TSL. This is configuring things for the protocol, the message protocol that our DIDCOMM agent understands. And I do that by passing in elements of the encrypted message that we created here. And part of that message is an encoding of who the recipients are in this recipient's byte string. So that creates the encrypted message. Then I need to turn that into just a plain old DIDCOMM message. and I get the JSON representation to that. So if we go back again and look at the TSL, what I've done is I've populated this structure, which is represented by a C# class. The value of that is assigned to the value of the excuse me, encrypted message. And that gives me the message structure that I'm going to pass in, into my DIDCOMM endpoint. So this is identical. I believe it's identical to what we saw before. I create my HTTP client. There's my endpoint that I'm targeting the URL for it. Instead of passing an empty JSON string, I'm passing my DIDCOMM message, which encapsulates the encrypted message, which encapsulates my notify message, my encrypted notify message. When that is received up here in the handler, remember the DIDCOMM handlers are DIDCOMM endpoint. My girlfriend's puppy's making a little bit of racket in the back here. So what we get is the DIDCOMM message, and from the DIDCOMM message request, we need to extract the encrypted message property. And we get an encrypted message. We're going to take that encrypted message, or we're going to create a new encrypted message from the DIDCOMM encrypted message and assign all the fields. So now we're moving back onto the Trinsic DIDCOMM side of the house. We're populating the recipients. Here we're going to show a count of the recipients collection, and we're going to show who the sender ID and the key ID is, because we need to know the DID keys, the DID:(key) keys for the sender and the receiver, the recipient, because when we go to do the unpack, we need to reach into the key vault. And we need to get the sender's public key and the recipient's secret key. Once we get the message decrypted, we'll get the plain text for the core message. From that core message, we're going to extract the basic message in the next 2 lines. And I believe we have a breakpoint nearby there. We'll put a breakpoint in here so we can see that what we're getting back at this point is the plain text VCA. This little paragraph of code here, this is showing how we take any Trinity structure, convert it into a cell, and persist it into local storage. So if you remember, we have a structure up here called cell. A cell, this particular cell just has one element, one property called EM, which is an encrypted message. So we're going to create an encrypted message that wraps that encrypted cell, and then part of the automatic code generation is that we get a save DIDCOMM encrypted message cell method built for us. We just pass in the cell. And when we create the cell, it'll automatically be assigned a unique 64-bit integer. So we can persist it. If we ask what is the type of the cell, we can take that cell ID, that's the extra long that is added to the beginning of our structure here by Trinity. We take that cell ID, I'm just going to print it out later on. I can count the number of cells that are in local storage and kind of print that out. A cell, when it's written into Trinity storage, has a type, and so this is how the Trinity runtime knows how to serialize and deserialize out of local storage. So at this point, let's run this and see if some of that makes sense. So let's just have a look and see what we've got here at the tree. So we have our agent started, And at this point, I've created a notify message, and I can see that the notify message has an ID, it has a type, it has a body, etc. So that was based on the key for Charlie and the key for the two recipients, as well as the JSON that the dummy JSON we're using for the VCA. So now we're going to loop through for each of those destinations, and what we're going to do here is create an encrypted package based on the notify message with Charlie's secret key, the recipient's public key. We're going to take that message out of that encrypted package. We're going to use that to build a DIDCOMM message, protocol message. And then we're going to convert that to JSON and use our HTTP to send it. So let's do that again. We are back up here in the handler where we've received that message. If we scroll up here, we can see that we've got the, you'll have to take my word for it, that's the sender ID for Charlie, and this is probably the one for Delta because it's the first time through. If we run that again, return the return code, we come in the second time, this would be for Echo. Again, this will still be Charlie's key, and this will be Echo's key, and we'll look up in the key vault with Charlie's key, and we'll look up in the key vault for Echo's key, and we'll unpack that message. We'll get the plain text for the decryption. That plain text is actually a protobuf byte string, and we're going to convert that byte string into a core message, which you can see there. And then we're going to take that core message and we're going to convert it into the basic message, and there we can see our VCA JSON. Run this once more, let that go to the end. If we look in the trace, we can see some of those keys that we're dumping out. We can see when we're persisting to local storage, here's an example of a key ID that's created for the cell type, and we can see that we now have two cells written out. And we'll stop the agent. So a bit of a quick tour of prototype 2. It's showing you a lot of things. It's showing you how to create keys. So if you go into the subject, you can see how we create keys. And we happen to be keeping them in just an in-memory key vault that's indexed by keys. What else did we see? We saw the beginnings of how we create a notify message at this higher level, the VCTPS message level. Part of our two-way protocol for doing secure, verifiable credential transport. And then we saw how we send a message to multiple recipients, how we pack or encrypt our notify message for each of those destination recipients. We go through the actual DIDCOMM encryption process. We create a DIDCOMM protocol message and take the JSON for that and just do an HTTP push. So with that, let me cut it off and look forward to seeing you when we talk about prototype 3.